Hello, students.
Yes, sir.
Good. Good evening. Yeah. This is extreme scientific. This is what?
Extreme science.
Good. And we are dealing with physics today. We are dealing with what? Good. So, as we are dealing with physics today, you know, the last time, there was a time we dealt with physics constant. What did I call it?
Physics constant.
What did I call it?
Physics constant.
And we start from number 1, we stop at number 17. Right?
Yes.
Good. So today, we are doing the part 2, the continuation of the constant, physics constant. So we are doing the part 2 today. So if you can kind of remind me about the constants from 1 to 17. So one after the other. So who is the first person that will you say your own? So let's divide it. Let's say 1 to 17. Divide by 2. That's what? 17 divided by 2. Eh? Between 9 and what? That's 8.5, right? Maybe one of you should say one from 1 to 8, and another person should follow from 8 to what? 17. So who's saying from 1 to 8? You are choosing 1 to 8. 1 to 9. Okay, let's do from 1 to 8 then. Yeah. Hold your book where you wrote it. Oh, you want to face on this, focus on this one. Oh, you understand what I'm talking about? The first constant I gave you from 1 to 17. So you are going to say 1 to 8. This is going to say 9 to 17. I'm listening.
Mass of the
Okay.
some quantity times 10 is per kilogram.
Okay.
ME, mass of the earth, 98 times 10 is per 4 kilogram.
Okay.
MP, mass of the 1.67 times 10 minus is per 7 kilogram.
Okay.
ME, mass of electron, 9.109 times 109 times 10 minus is per 1 kilogram.
Okay.
Mn, mass of neutron, 1.67492 masses times 10 minus 7 is per minus 10 is per 7 kilogram.
Okay.
Mu, mass 1.88 times 10.
Muon mass. Okay.
One mass 1.88 times 10 minus this per 28 kilogram. O, radius of hydrogen atoms 5.29 times 10 is per 11.
Okay. That's about.
7.
Okay.
H, Planck constant 6.626 times 10 minus 6 per 34.
Wait. 6.62.
6.626
6.626.
times 10 minus 6 per 34.
Have your seat. Laugh for yourself. Anyway, by the time we enter what is called scientific notation, are you understanding me?
Yes, sir.
So you know that any number beside decimal, once there's a decimal, you don't call that number as if you are calling tens, hundreds again. You call it as what? Decimal number. Are you understand what I'm saying? So you don't say 1.62, no. 1.62 this thing. It may be 20.43311. You call this number one after the other. But you are not going to call the number as if they are 100, tens, and what? And units. You don't call those numbers again like that. So the next one, number 9.
N, Glucose and
5.051 times 10 raised to the power minus 27.
Okay.
NE, involved magnetron, 9.27 times 10 raised to the power minus 24.
Okay.
TH, Planck constant. Planck constant rational is
Rationalize.
1.055 times 10 raised to the power minus 34.
Okay.
Alpha, fine structure constant, 7.297 times 10 raised to the power minus 0.
Okay.
Lambda C,
Lambda C.
Compton wavelength,
Compton wavelength.
2.426 times 10 raised to the power minus 12.
Okay.
Small letter RB, classical electron ranges,
Okay.
2.878 times 10 raised to the power minus 15.
Okay.
Gamma P, proton
Geomagnetic wavelength. Yes.
geomagnetic wavelength, 26.7, okay, 2,267,252,211.
Okay.
Dada CQ,
With that number of decimal points, you call it according to the proper order. It may be in millions, so
2,267,522,212.
wait a minute, again, let me hear the
267,000,522,212.
Okay. 212 units. Again,
267,522,212 units.
good. That's how to count numbers. So you can even count number in form of a quintillion, quadrillion, trillion, billion, million. You understand what I'm saying? Hundreds of thousands, tens, 100, tens, and what? And units. Once you can know how to count numbers, are you listening to me? Once you can know how to count numbers, there's no scientific experimentation that has to do with figures that you'll be able to solve. I understand what I'm saying. For example, if you're a surgeon and you have to deal with the brain, and you have to, because if you look at the brain now, the brain contains what is called the neuron. What I call it? And then billions. You understand what I'm saying? Any small misalignment is affecting your brain. So you'll be able to, if you know how to count numbers, you'll be able to know how those numbers are in order. That is, we call it number ordinal, order, in proper order. I understand what I'm saying. So it's good to know how to count. Be very good with numbers and be able to even solve a lot of problems that has to do with mathematical equation. So go on, I'm listening.
Lambda CP,
Yeah.
proton
Proton quantum wavelength, okay?
1.3214 times 10 raised to the power minus 15. Good. Lambda CN, neutron quantum wavelength, 1.3196 times 10 raised to the power minus 15.
Good. That's number 17. Clap for yourself, please. So without wasting your time, we will proceed. This is the part 2 of the previous topic. So we are starting from number 18. What I call it?
Number 18.
Good. So we have uppercase R infinity. What I call it?
Uppercase R infinity.
Uppercase R infinity.
Uppercase R infinity.
Very, very well. Uppercase R infinity.
Uppercase R infinity.
It is called Rydberg constant. Rydberg constant.
Rydberg constant.
10,973,731.57. Again?
10,973,731.56.
0.57. You don't call it 57. 0.57.
0.57.
How are we not calling it 57? Because once you have a decimal point here, you are dealing with what? Decimal. In computer, it is called float. What I call it?
Float.
Floating point unit. FTP. FTU. Floating point, that is, it is there decimal. Are you understand what I'm saying? Again, uppercase R infinity.
Uppercase R infinity.
Look at this thing. See, but anywhere you see this little symbol, it means infinity. What I call it?
Infinity.
Say infinity.
Infinity.
Say infinity.
Infinity.
It means that is very gigantic and that number is very big. It means that number is very what?
Big.
Anyway, say infinity. You are solving equation. That means that is very astronomical. What do I call it?
Astronomical.
Say astronomical.
Astronomical.
Say astronomical.
Astronomical.
Good. So that's the meaning of what? That is what? Infinity without ending. It's continue to go just like that. I understand what I'm saying. Good. So uppercase R infinity, we have Rydberg constant. Rydberg constant again.
Rydberg constant.
Rydberg constant.
Rydberg constant.
10 million. 10 million.
10 million.
973,000.
973,000.
731.57.
731.57.
Rydberg constant.
Rydberg constant.
The next one, number 19. We have lowercase u.
Lowercase u.
Lowercase u.
Lowercase u.
Atomic mass unit.
Atomic mass unit.
Atomic mass unit.
Atomic mass unit.
1.66
1.66
times 10 raised to the power minus 27
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 1.66
1.66
times 10 raised to the power minus 27
times 10 raised to the power minus 27
1.66
1.66
times 10 raised to the power minus 27
times 10 raised to the power minus 27.
as atomic mass units.
Atomic mass unit.
In physics and in chemistry, you meet this guy. Atomic mass.
Unit.
Don't forget it. Please put it at the front of your mind. Because when we are dealing with subjects like molar volume, molar mass, we will deal with atomic mass units. Don't forget it. As you are dealing with it in physics, you will deal with it in what? Chemistry. So let's proceed. We have mu p.
Mu p.
Mu p.
Mu p.
Don't forget, I didn't say mu no. Mu.
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 It's a letter in the Greek language, Greek alphabet. You know what I'm saying? It's alpha, beta, gamma, delta, iota, kappa, lambda, mu. After lambda means L, mu means what? M in Greek alphabet. So mu p.
Mu p.
Proton magnetic moment.
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 Don't worry. You may not understand what is meaning of movements later. But later we are going to explain to you the meaning of what movement, because in physics there is a topic that is called moments. We will deal with momentum, we will deal with moments, and the moment of inertia, kinetic energy. We will deal with all those things in physics, and we are going to use solve equation with them. So we have proton magnetic moments. Again.
Proton magnetic moment.
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 Good. That is 1.411
1.411
times 10 to the power minus 26.
times 10 raised to the power minus 26.
Again.
1.411 times 10 raised to the power minus 26.
Again.
1.411 times 10 raised to the power minus 26.
Good. The next one, number 21, we have mu E.
Mu E.
Mu E.
Mu E.
Electron magnetic moments.
Electron magnetic moment.
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 Minus 9.28
Minus 9.28
times 10 to the power minus 24.
times 10 raised to the power minus 24.
Minus 9.28
Minus 9.28
times 10 to the power minus 24.
times 10 raised to the power minus 24.
Number 22. Mu N.
Mu N.
Mu N.
Mu N.
Neutron magnetic moments.
Neutron magnetic moment.
Neutron magnetic moment
Neutron magnetic moment.
minus 9.662
Minus 9.662
times 10 to the power minus 27
times 10 raised to the power minus 27
minus 9.662
minus 9.662
times 10 to the power minus 27.
times 10 raised to the power minus 27.
Good. The next one we have mu mu, not mu mu. How like this? Mu mu. It means muon magnetic moment.
One magnetic moment.
What's the meaning of the word muon? Well, there's something called fundamental particles. We will deal with it when we are dealing with alpha particles, beta particles, and gamma radiation, especially atomic. And when we are dealing with something that's atomic, all this radiation. I understand what I'm saying.
Yes, sir.
So muon is one of the fundamental particles. Muon is one of the what?
Fundamental particles.
Good. So we will deal with it when we are dealing with high level physics. Right? Do you understand me?
Yes, sir.
High level what?
Physics.
Even in chemistry too. They deal with this they call muon. I understand what I'm saying. Say muon.
One.
So there's another one too called gluon. Don't worry. When we enter those higher level physics, we will deal with those things. So say muon.
One.
Magnetic moment
Magnetic moment.
minus 4.490
minus
Minus 4.4.
190
minus 4.490
Minus 4.490
times 10 to the power minus 26
times 10 raised to the power minus 26
times 10 to the power minus 26.
times 10 raised to the power minus 26.
What are they talking about here? You see that when I say minus raised to the power minus 26, that will be 0.0000000000000000000 in 26 places. Are you understand what I'm saying? 0.0000000 before you now reach 9.622. So it cannot be minus 0.0000000000000000000. You now reach 9.62. 662. Are you understand what I'm saying? So that means that thing will shrink. Is that not so? So when you say minus something, it means that thing what? So when you say 10 to the power minus 27, you see that thing you can't see it with ordinary eyes. Can you see it with ordinary eyes? No. Because it is operating, it is working. Bring that magnet. The big one. Do you notice something? Right? This is called magnetic. This is a magnet. But something is going on here. If I want to separate, it's two magnets. Can see that this magnet is what? Attracted. That means this one is the north, this one is the what? South. They have what? Can I separate it easily like that? Why? There's a very strong magnetic force. Are you understand what I'm saying? So when we enter into those realms, when we're dealing with magnetic electric power, electric energy, I understand what I'm saying?
Yes, sir.
You notice that you'll be dealing with all this thing called a magnetic moment, one electric magnetic moment. Bring the other one. You notice something like is what? Attracts. Look that look at it. It still attracts. Take this, give it back. Let me explain it, show you this. Look at something here. What is it doing? Eh? Is what? Is repelling. But you can't see that force that's making it to be repelling each other. Can you see? I'm trying to, they are not joined together. So that thing, that force is invisible. Do you understand what I'm saying? It is called magnetic flux. What do I call it?
Magnetic force.
What do I call it?
Magnetic force.
Flux. Say flux.
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 Where's my marker? Magnetic
Flux.
magnetic flux. See, I try to bring it together. It's not coming together. I try to force it. The thing is pushing. It's what?
Pushing.
It's what?
Pushing.
So by the time we enter the magnetic realm very well, when we are studying about magnets, so you see that all this thing I'm explaining to you, they have their own usefulness. Are you understand what I'm talking about? They have their what? They have their usefulness. So there is something that is practical. You can see, you can do practical about it. Are you understand what I'm talking about here? So we have more magnetic moment. So you can't see that force, you can't see that this thing, but you can feel its impact. You can do what?
Feel its impact.
Yeah, good. You can feel its impact. So they are fundamental particles, but the force, you can't see that force, but you can see what? You can feel the impact of that force. So that in high level this physics, we're dealing with nuclear energy. These are the disciplines you need to understand. Are you understand what I'm saying?
Yes, sir.
When we are dealing with electron, proton, neutron, muon, gluon, magnetron, are you understand what I'm saying?
Yes, sir.
All these fundamental particles. There's another one called quark, lepton, neutrino. By the time we enter into those high level this thing, you'll be able to understand. But I have to introduce you to the constant so that you know the constant. So mu muon magnetic moment
One magnetic moment.
minus 4.490
minus 4.490
times 10 to the power minus 26.
times 10 to the power minus 26.
Good. Number 24. We have uppercase F
Uppercase F.
or capital letter F.
Capital letter
F.
Capital letter F.
Capital letter F.
Faraday's constant.
Faraday's constant.
Who is Faraday? Faraday is a physicist. He was one that is prominently known as the person that invents electricity, the first person. Why? There's another man called Tesla that did a lot of work too about electricity too. So this are why with copper coil. With what?
Copper coil.
So he was one that give us the Tesla that make us to be enjoying all this electricity we are enjoying now, especially using what? Copper coil. Inductor motor. I know what I'm saying? Generator. So it's that man that invented all these things. Are you with me?
Yes, sir.
But Faraday is one that first did some experiments to discover electricity that is well known. There's also another president of the United States of America, if I can remember his name, that man too, accidentally discovered electricity. He also defined electricity. One day he was doing some experiments, he was using a kite. All of a sudden, lightning nearly killed him. Lightning, you know lightning. When there's between lightning and thunder, right? So lightning nearly killed that man too. They also did a lot of work on what? Electricity. So the three of them like that. They also got president of one of the Benjamin Franklin. What do I call his name?
Benjamin Franklin.
What do I call his name?
Benjamin
You
Franklin.
can see his face, his picture of his face in all these dollar. Do you understand what I'm saying? So that man too, he did some experiments. The president of what? He loves scientists. He did a experiment and he accidentally discovered that what makes lightning is it contains electricity. So then followed by Faraday, then followed by what? Tesla. Are you understand what I'm saying?
Yes, sir.
So Tesla now did a lot of work. Then this man Thomas Edison, we celebrate him for issue of bulb. All these I'm not talking about this, the modern bulb we are using, the light and everything that I'm talking about all those argon, this light bulb, all those big argon bulb, all this light bulb, all those big bulb of those this. It was what I thought that invented it. Some say he stole the thing from Tesla. You know what I'm saying? But it was one that was prominently known that is one that invented that bulb. So that's Michael Faraday for you. So we are now using his constant. What I say?
Is constant.
We are using his what?
Constant.
So his name is called Faraday. So Faraday's constant
Faraday's constant.
96,000 485.3415.
485.3415.
481. 96,000 96,000 485.3415.
485.3415.
Or we approximate it to 96,500. You come across this Faraday constant both in physics and in what? In chemistry. Don't forget it. But when I begin to teach you some things about electrolytes, what do I call it? What do I call it? What do I call it? Say electrolytes. Electrolytes. What is the meaning of electrolytes? Have you seen water battery before? Have you seen water battery? Have you seen water battery? You've not seen water battery. All those batteries they use to start in a car, they are what? Water battery. There are different types anyway. We have some that are dry battery, that's dry cell. Like the one that egg here I'm using in the room. That one is what? It's a dry gel. You know, it's not water battery. That's what they call it, AGL. So there's another one that's called lithium battery. What do I call it?
Lithium battery.
But most of those batteries that has to do with chemical, they call it electrolytes. So this man, Faraday, we use his contact when we are doing those calculations. When we are doing electrolysis, what do I call it?
Electrolysis.
Say electrolysis.
Electrolysis.
Say electrolysis.
Electrolysis.
So when we are dealing with electrolysis, we are going to use this man's constant. The next one, we have E. Lowercase e.
Lowercase e.
Elementary charge.
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 1.6027 times 10 raised to power minus 19. Again.
1.6027 times 10 raised to power minus 19.
Again.
1.6027 times 10 raised to power minus 19.
We have the next one. Uppercase N and uppercase A.
Uppercase N and uppercase A.
Say Avogadro's constant.
Avogadro's constant.
There's a man called Avogadro. This man is the man that discovered what's called Brownian motion and the way molecules move. His name is called what? Avogadro. He did a lot of works. You do most of those calculations, most of those experiments, most of those calculations that he did. When we enter this even in chemistry, I'm going to do a lot of work. As I see, we use this. We will come across this constant. Uppercase NA.
Uppercase NA.
Avogadro's constant.
Avogadro's constant.
6.022.
6.022.
Times 10 to the power minus 23.
Times 10 to the power minus 23.
6.022.
6.022.
Times 10 to the power minus 23.
Times 10 to the power minus 23.
6.022.
6.022.
Times 10 to the power minus 23.
Times 10 to the power minus 23.
The next one, uppercase K.
Uppercase K.
Boltzmann constant.
Boltzmann constant.
There's a man called Boltzmann. Let me remember his name. His name is called what? Boltzmann. That guy is also very brilliant. Boltzmann constant.
Boltzmann constant.
1.380.
1.380.
Times 10 to the power minus 23.
Times 10 to the power minus 23.
1.380.
1.380.
Times 10 to the power minus 23.
Times 10 to the power minus 23.
Next one we have uppercase V, lowercase n.
Uppercase V, lowercase n.
Molar volume of an ID gas.
Molar volume of an ID gas.
Again.
Molar volume of an ID gas.
Again.
Molar volume of an ID gas.
at STP.
at STP.
What's the meaning of the word STP? When you see STP, it means standard temperature and pressure. Again,
Standard temperature pressure.
again,
Standard temperature pressure.
again.
Standard temperature pressure.
So, molar volume of an ID gas at STP
Molar volume of an ID gas at STP.
is equal to 0.0022413999.
0.0022413999.
Again,
0.0022413999.
again,
0.0022413999.
again.
0.0022413999.
Good. The next one, uppercase how?
Uppercase R.
Universal gas constant.
Universal gas constant.
Universal gas constant.
Universal gas constant.
8.314472. Again,
8.314472.
again,
8.314472.
again.
8.314472.
Good. The last but not the least, lowercase c naught.
Lowercase c naught.
Velocity of light in a vacuum.
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 299,000. Sorry, 299,792,458.
299,792,458
units. Again,
299,792,458 units.
good. Most time they put this in meter per
Seconds.
seconds. Can you see the speed? Just a single light is running. If you can run in the speed of light, what do you think we have? Huh? You say flash. Yeah. They get this idea that they movie ideology from each of the speed of light. They can run at the speed of light. What do you think we have? Time will pause. You'll be able to see the future, present, and the present, past, present, and future at the same time. You'll be able to see the alternate future. You know what I'm saying? If you are able to move, you'll be faster than a bullet. A bullet what? You pause, you see it like this. It will pause. You go from here to America and come back. And the bullet will pause. So you'll be able to see future. You'll be able to go to the past, present, and the future at the same time. So this thing is mind blowing. That's why great scientists that work in this on these laws and theorem, that work on this discovery, invention, laws, they are very brilliant. What did I say?
They are very brilliant.
Yeah, people like Sir Isaac Newton, Albert Einstein, Dirac, these great people. They are extremely very what?
Brilliant.
Brilliant. So put that at the front of your mind. I want you to study these things and know it. Imagine you having everything in your mind, in your brain. You know it. Just imagine. You'll be solving a lot of equations. Anything that has to do with physics, you just it. Are you understanding me? Yes. So I will stop here. Is there any question? Anything that you feel? I should ask question about this. Is there any question? Is there any question?
What do you know? Movements.
Huh?
Movements.
Moments. There's something called moment of inertia. That is in physics, when we are dealing with a momentum, you'll be able to understand about how forces work with acceleration, with velocity. I understand what I'm saying. So we'll be able to calculate the vector of those forces. So it's a separate topic on its own. When I say moments. So by the grace of God, I will find time, we will deal with it. And we are going to solve a lot of calculation concerning moments of inertia, momentum. You know what I'm saying? Be able to understand how. Have you got ground paper before? You've got ground paper before. How the pulley system work. You know what I'm saying? You see, when they draw the engine for that paper, you see, look that the small one is connected to the shaft. It's connected to the grounding, the thing that is grounding the paper. So all these things is under momentum, and all stuff that you're going to study how those things operate. That's why you are going to study about friction. I understand what I'm saying. Lubrication, pulley system. You understand what I'm saying? How you are going to start to know about how elevators are operating. You understand what I'm saying? You used to see it in film. Elevator. Have you entered an elevator before? Huh? You follow me, this you have entered. How those lifts operate. So they operate using all this law. Moment of what? Inertia, kinetic energy, potential energy, all this thing. Newton first, second, third law of what? Motion. We are going to deal with that moment. I understand what I'm saying.
Yes, sir.
Now that moment is in different form. We can do it's also solve moment of electricity, of electron, and solve moment of neutron, and solve moment of one. I understand what I'm saying. So we can also solve moment as you are sitting there now. There's something called moment of inertia. It's also affecting the gravity and all these things. How you are balancing on this chair. I understand what I'm saying. How the gravity is operating on you and this chair too is giving an up thrust to make sure your weight balance. I understand what I'm saying. So all these things we studied under what? Momentum, forces, acceleration, velocity. I understand what I'm saying. So that's what we are going to study this thing. Any other question? Before we call it a day. So we'll do part 3 in the next class. So this was part 2. So are you okay? So let's call it a day. Or call it a week. This way.